The quantile regressions R squared, also known as pseudo R squared, denoted as R of p, is computed as this, wherein the numerator is the sum of weighted distances for the full p-eth quantile regression model, and the denominator is the sum of weighted distance for the model that includes only a constant term. Based on the equations from the previous slide, we know that both the numerator and denominator are non-negative since we are getting the absolute values of the distances. Also, because the sum of the weighted distances is minimized for the full fitted model, gaya ng nabanggit sa earlier videos, v superscript 1 of p is never greater than v superscript 0 of p. Thus, like the r squared used in OLS, the pseudo r squared only ranges from 0 to 1, wherein the larger the value of the pseudo r squared, the better the model fit is. Here we have the comparison of the r squared and the pseudo r squared. Unlike the r squared, which measures the relative success of two models for the conditional mean function in terms of residual variance, the pseudo r squared measures the relative success of the corresponding quantile regression models at a specific quantile in terms of an appropriately weighted sum of absolute residuals. Also, the r squared constitutes a global measure of goodness of fit over the entire conditional distribution, while the pseudo r squared constitutes a local measure of goodness of fit for a particular quantile. To generate the pseudo r squared in R, we will be using the following codes. Here we compute for the pseudo r squareds of the 0.10, 0.50th, and 0.90th quantiles of the Anscombe dataset that we used in our first example. For the 0.10 quantile, we got 0.44799909, which means that at 0.10 quantile, 44.80% of the variability in the y sub 1 can be explained by the x sub 1. For the 0.50th quantile, we got 0.4627129, which means that at 0.50th quantile, 46.27% of the variability in the y sub 1 can be explained by the x sub 1. And for the 0.90th quantile, we got 0.5277545, which means that at 0.90th quantile, 52.78 of the variability in the y sub 1 can be explained by x sub 1.